Okay, this is part 2. This started our unit 2 on radicals. If you're given radicals and it asks you to simplify, the steps are like this. You have to break down what's inside. So you have to factor the inside stuff. That is using a factor tree. Then you look for groups of homies. So you're looking to break out people. Break out groups of homies. And then that group size is going to change depending on the shelf number. So the shelf number is the size of the group. And you're going to actually break people out. Only one breaks it out. Only one of each group, I guess I should say. And then your last step is to multiply everybody together. So multiply the outsides together. And the leftovers inside. All right, let's try one. So 289, we're going to break that down now. I don't think 2 goes into it because it's not even. And I'm not really sure. So I would pull out a calculator and do 289 divided by 2. No. 289 divided by 3. No. And work your way up that primes list that I gave you. When you do, it turns out that 289 is actually 17 times 17. So I've got this group of 17s. One makes it out. The other one dies, but nobody's left in jail, so I don't have to draw it. Or write it, sorry. Don't forget this 2 that's out in front. Everybody on the outside gets multiplied together, and that becomes 34 right there. Okay, this one we're going to take 80 and break that down. So 80, let's see, that's 8 and 10. You might have thought of other numbers. It doesn't matter. 8 is 2 and 4, which is 2 and 2. Got it. And 10 is 2 and 5. So this is the cubed root of 80. Turns out 80 breaks down into 2 times 2 times 2 times 2, right? 1, 2, 3, 4 2s, and then a 5. So my group size is 3. I've got a group of 3 2s right there. One makes it out. The rest of them go away. And then all I'm left with inside is a 2 and a 5, and you multiply those together to make 10. There was nobody out in front, so there's nobody else to combine, and that would be your answer. Okay, number 3 here. We're going to break 72 down. Trying to make sure I have enough room. 72 is actually 2 and 36. 36 is 6 and 6. 2 and 3, 2 and 3. So this guy breaks into, let's see, 2, 2, 2, and then 2 3s. So 2, 2, 2, 3, 3. And it's got 6 x's. So 1, 2, 3, 4, 5, 6, and a single y. Now my group size is 2 again, because there's no number out on the shelf. You assume it to be a 2. I've got 2 2s here, 2 3s. So I've got 1 2 makes it out, 1 3 makes it out, and I've got a pair of x's there, another pair of x's, another pair of x's. Then if you multiply everybody that's on the outside, you go 2 times 3 is 6, x times x times x is x squared, or sorry, x cubed. So our final answer is 6x cubed. Now we still have this 2 and this y underneath the radical. So we got to still put those inside the jail. That's it. Okay, down here, this is the fourth root. Now you'll notice that this is x to the fifth, y to the 8th, and z to the 14th. You can write it all the way out, doesn't matter. You can write out all the numbers. So we'd have a 7, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. It's a lot. And then there's going to be 14 z's. Now I'm going to look at this and say, okay, the group size is 4. So I'm going to write it out like, okay, there's 4 z's. I'm just going to simplify it and write it in this kind of shortened way. So then I'm going to say, okay, there's another 4 z's. I'm at 8 so far, right? 4 plus 4 is 8. Then I'm going to do another 4 z's. So let's see, that's 4, 8, 12. And I'm supposed to go to 14, which means I need 2 more z's in there. So times z times z. I did that because that's going to simplify this process for me. 1, 7, that doesn't count, right? I've got 4 x's here, so 1 makes it out. I've got 4 y's here, 1 makes it out. Got another set of 4 y's, 1's going to make it out. Now look at these z's. If I had written these all out, this would have been 4 z's right there, 1 makes it out. This one would have been 4 z's right there, 1 makes it out. This is 4 z's, only 1 makes it out. And then I've got 2 left over in there. So rather than writing out 14 z's, I just went in groups of 4. So okay, here's 4 z's. Here's another 4 z's, that's 8. Here's another, that's 12. Just a way to save you some work. I mean, you can write out the 14 z's and do it that way. It really doesn't matter. So I've got 1x outside, a y squared. Oops, this is supposed to be purple. Gotta color coordinate. So we've got 1x outside, a y squared, and 3 z's, so 3z to the third. Now we've still got people in jail. We've got this 7. We've got a single x, and then those 2 leftover z's, so z squared. And that's your final answer. Okay, moving on. This one, there's a negative out in front. All that means is in the end, your answer is going to be negative. So this guy's going to get carried down to the bottom. Now we're just going to break this stuff apart. 72, we already broke down in this previous problem. So I'm going to write that out. 72 was 2, 2, 2, 3, 3. Then we've got a group size of 3. So, I mean, 4 A's is easy to write out. So I'm just going to write out the 4. 6 B's probably isn't that bad. 1, 2, 3, 4, 5, 6. But when it comes down here to these 14 C's, I'm going to write it down in groups of 3. So here's 3 C's, C cubed, right? Here's 3 more C's, that's 6 total. Here's 3 more, that's 9. Here's 3 more, that's 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I need 14, which means I've got 2 left over. So again, you can rewrite it with all 14 C's expanded out. I'm just kind of doing a shortcut and saving me that whole step of, oh, here's 3, or here's 3 C's, here's 3 C's. I'm just doing it along the way. So 3 2's, 1 makes it out. Nope, on the 3's, we've got 3 A's, 1 makes it out. In the B's here, we've got 1 group of B, 2 group of B's. So a B and a B. Okay, the C's. I've got 3 C's here. 1 makes it out. 3 C's here. 1 makes it out. 3 C's here. 1 makes it out. So altogether on the outside, I've got a 2, an A, B times B, so B squared. And then I actually ended up with 3 C's on the outside. So C, 3 cubed, whoops, C cubed. And my radical is still there with a group of size of 3, shelf number. And I've got 3 and 3 inside, and you multiply those to make 9. I've got an A, oops, And then I've got, whoops, that guy went down there. Whoops. I had 4 C's. Why didn't you guys stop me? Why didn't anybody pay attention? It's supposed to be purple anyways. All right. So we've got 2a, b and b, which is b squared, 4 C's, 1, 2, 3, 4, and then our leftovers. There was a 3 out on the shelf. I had 2 3's, and multiplying back together, that makes 9. An a there, and then 2 C's, all the b's went out. So c squared on the inside. Okay, and I'm not quite done because remember I had that negative out front. He's still there. He just goes in front of our answer. That's negative 2ab squared, c to the 4th, and then cube root of the rest. Okay, same idea. Here we go. Group size is 3. So I'm going to break this down. The 5 is just 5. X to the 5th. Now I'm going to do the shortcut way, and I'm going to say, okay, here's 3 x's. There's 5 total. So there's my other 2. Y to the 6th. Here's 3 of them. Here's 3 more of them. And that's 6 altogether, so I don't need to do any more past that. The z's. Here's 3. Here's 3. 7, so there's 1 more out there. Okay, now looking for groups of 3. I already found them. I have a group of 3 x's there. Only 1 makes it out. The rest of them are gone. A group of y's. Another group of y's. 2 groups of z's. And a z. And left over on the inside will be still a cube root. So we've got x, y squared, z squared, and then we've still got the third root of a 5x squared z. 5x squared z. Okay, next one is rewriting in radical form. So we had this form where it was a to this fractional power, a, and we used m and n. And that's equivalent to an n out on the shelf and then a with an m power on the inside. And then there was also this negative version, so negative m over n. When it's a negative power, that means it's 1 over positive. So it gets rewritten like this. This means a fraction. So negative powers mean fractions. Okay, this one right here, I'm going to have my radical. Looks like 12 is out here on the shelf. And we're going to have a power of 5 on the inside. But you have to determine what goes on the inside. Is it the x? Is it the 3 and the x? Well, it's actually just the x that's being raised to the power. So the x is going to go inside and the 3 stays out front. Compare that to this one over here, number 8. Notice that this guy has parentheses. So this time, 15's out on the shelf, 7's on the inside, but the whole thing, 2x in parentheses, goes inside. Okay, this one's got a negative, so it's going to be a fraction. Move it over to the other side, it becomes positive, and then it's 1 over 2 out here. You don't have to write the 2, it's usually not written. So we get 1 over square root of y to the 5th. Same idea here, it's negative, so we're going to move it to a fraction. And then using the formula, here's a radical with a 9 out on the shelf and y to the 4th on the inside. Oh, look, this is like that first one, except for now it has parentheses. So it's going to be 13 on the shelf and inside 3x to the 5th power. All right, this one right here, look, it's negative 2, but there's no parentheses. So my answer is just going to have negative 2 out in front. Looks like a 3 out on the shelf and x to the 7th on the inside.